Hi, today I want to show you the ICS 105 set from Langer EMV-Technik, which is a set of an IC scanner. This set consists of the scanner itself, the ICS 105, a power cord, a microscope camera, a set of cables, a set of claws for big one and for small one probe holder to hold the Langer Nearfield probes, a set of Allen keys, the golden ground plane, a USB stick with software, a small triangular mirror, a set of screws, and all necessary manuals. To set up the IC scanner for the first time, we start with connecting the Z-axis to the scanner hardware. So we take this plug and connect it to the left socket on the top of the scanner. Here that it is click and you know it's well connected. Secondly, we take the microscope camera, put it into the camera holder from the top, and connect the plug to the right socket on the top of the scanner. Also here, a click is hearable. To adjust the camera, you have several options. At first, you can use the two thumb screws on the top to move the camera in front or backwards. Secondly, you can use the thumb screw in the front to move the camera upwards or downwards. Thirdly, you can use the big thumb screw to move the microscope camera in a different position and to define the angle of the camera. With the thumb screw on the top of the camera, you can adjust the focus. After this, we take the coaxial cables. The thin SMB cable has to be connected to the lower plug on the left side of the IC scanner, and the thicker SMA cable has to be connected to the left side SMA plug. Both coaxial cables can be fixed with a cable fixture on the top of the rotation unit. At least the USB cable and the power cord has to be connected to the right side of the scanner. Finally, the scanner is ready . To prepare an IC EMC measurement with Langer ICR micro Nearfield probes, we need additional devices. We need a spectrum analyzer, we need an IC under test, and we need an ICR probe. At first, we put the PCB with the IC in the golden ground plane and put the ground plane into the scanner. After this, we can attach the ICR micro near-field probe by using the thumb screws on the top of the rotation unit. For better handling, connect the coaxial cables before fixing the probe with the screws. After screwing in both thumb screws, the ICR probe is fixed at the rotation stage, and now we can lift the security cap and the probe is ready for measurement. To guide the measurement signal to a spectrum analyzer, we have to attach the spectrum analyzer cable on the left side of the IC scanner. Now the setup is finished. We have attached the ground plane with the IC under test. We have attached the ICR micro near-field probe, and the spectrum analyzer is connected to the ICR probe via the SMA cable. To prepare the scanner with a measurement with a Langer near-field probe, we use the probe holder, which can be simply connected to the rotation unit with the thumb screws. So simple, put the probe holder on the top of the rotation unit and fix the probe holder with the thumb screws. Finally, connect the thin coaxial cable to the probe holder to have the information of the collision detection afterwards. To set up a measurement, we need some more devices which are not delivered with a IC scanner. So we need a spectrum analyzer, a Langer near-field probe, and a device under test. To attach a Langer near-field probe to the scanner, detach the metallic rod and put the probe into this rod. Fix the probe with a screw, first by hand, and finally with a small screwdriver. Connect the probe with the SMA cable. And put the metallic rod back into the holder. To guide the measurement signal from the near-field probe to a spectrum analyzer, we connect the cable from the spectrum analyzer to this SMA adapter on the left side of our IC scanner. To attach a PCB board to the scanner, at first we have to detach the adapter for the ground plane, and after this we can set the PCB board on top of the universal holder. To fix the PCB board at the universal holder, we use the claws, and in our case we use the big claws. Put them from the side to the PCB board and fix them with the screws, which are delivered with a set. After fixing the PCB board with all 4 claws, the device under test has to be powered up and is ready for measurement. To install ChipScan scanner, insert the USB stick into your PC or download the installation file. Browse to this installation file and double-click it. The software is completely installed. The software starts with this view. On top, we have later on the 3D view of our measurement results. In the middle, we have a trace view, and in the lower part, we have the dataset manager. On the right side, we have the device control, if we have a connected spectrum analyzer, and the scanner control. Before searching for devices with the software, we have to connect the scanner via USB cable to the PC and the spectrum analyzer with a GBIB cable or an Ethernet cable, also to the PC. Then we can click on Devices and open the Device Manager. We use an Ethernet connection, therefore we have to type in the IP address of the spectrum analyzer. Then we can click on Detect Devices, wait for some seconds, and then we can see that the software has found a Rohde & Schwarz spectrum analyzer, the video device of the scanner, and the Langer ICS 105. If all devices are correct found, we can close the device manager with a close button. With connected devices, we can open the video view for the integrated camera, and we can see on the right side of the software the device control is activated. Here we can type in the settings for the spectrum analyzer and set by clicking the Set button. Also, the scanner widget is activated for full control we have at first to calibrate the scanner by clicking the calibrate button. After the scanner moves to its home position, all the arrows are activated and the scanner can be moved by a simple click to one of these buttons. The movement range can be set with this edit field, and the next movement will be done with this range. To move to the absolute position, simply click to this red teardrop and type in the position where I want to move to. The rotation will be done with these two arrows on the bottom and with the angle value on the lower edit field. The camera can be controlled on its brightness by a simple click and move the slider, and we can switch off the camera by a simple click this value and reactivate by click again on camera off. To prepare a 3D scan in ChipScan scanner, click on Window and opens the Scan Manager. In the upper window, we see later on the existing setups, and in the lower window later on we will see the scan results. To add a new scan setup, simply click the red plus. A new window is open and we can type in the setup name and some additional information like the device under test, the probe, and a comment. Then it's time to define our volume. We can set up the size of the volume in X, Y, and Z direction, and the distance of each point to the next one. So for example, we set up a measurement volume of 10 millimeters by 10 millimeters by 5 millimeters with a distance to 1 millimeter between each points. Now we have defined our measurement volume and we can set up the movement strategy. Here we have two possibilities. For example, a normal volume scan, like this presented here. We start from the lowest possible point and then make a 3D volume scan. The second possibility, if a Langer Nearfield probe is connected, is to use a volume scan with vertical collision detection, where we start at a well-defined point in the middle of our measurement volume and always go from the higher part to the lower part. And within this setup, we can detect the device or the PCB board and stop the measurement at defined height. If we are finished with all the settings, we simply click OK, and the setup will be shown in Setups in the Scan Manager. To change an existing setup, simply click on the pencil icon. On a marked setup will be open, and we can change all existing stuff again. Simply click OK, and then changed setup will be saved. To run a scan, mark the scan in the setup window and press the start button. If we have activated the collision detection, this is necessary to simply lift up the probe once and remove it. Now the scan is started and the measurement runs. In the process window, you can see the estimated time and the process bar. As you can see on the video screen, the movement is always from top to down. At each point, the collision detection will be evaluated and the scanner stops if a collision is detected. After the measurement is finished, or after a file is loaded via File and Open, the complete measurement data is displayed in the 3D visualization in the top window of ChipScan scanner. Each current point in this view indicates one real measurement and displays the value at a certain frequency. The frequency can be changed simply with a slider or by typing in the desired frequency value. If a frequency range is of interest, we can simply activate max value and can define the frequency range with the two sliders. In this case, the maximum value of each trace in the range of 200 and 300 megahertz is presented in the 3D view. For a faster view, we can combine these single measurement points either with ISO contours or with planes. We can sweep through these planes by simply click with a left mouse click and holding the box. As you can see here in this view, we have a lot of white spaces, which are due to the fact that at this measurement point, there was no measurement possible due to the fact that a collision detection was activated. Also, a combination to a 3D view is possible. The settings for this 3D IC surfaces can be done in the settings, where we can change the number of surfaces and the opacity of the surfaces. To get detailed information at a special point of interest of the measurement volume, we activate the measurement point again, choose the point of interest, and with the right click and add to visualization, we can simply copy the information from the 3D view to the trace view. Now it is possible to take a second trace, open the scan manager, color, and to compare two different traces. After the data evaluation is finished, save the file via File and Save As, and the data can be reloaded next time. Thank you for attention. Goodbye.